Okay, so let's get started. So just a couple of reminders. We will have a class test number 1 on coming Monday. So the test will be available, right? Almost you have to allow, so pick one, the available time and the test will. Okay, so let me go over 1.4, briefly. So the 1.4 is about, the continuity, the continuous, of the given functional graph. Okay. If the given function f is continuous at the particular point C, if it satisfies these three conditions, okay? First of all, the function should be defined at that point C, and the limit of that function, when x approaches C should exist, and also the limit value of the function should be equals to the function value at that point. Okay, remember last time I explained you the function value and the limit value are two different things, right? But if the function is continuous, those two values supposed to be equal, right? So if you are asked to show that the function is continuous at a particular point, you need to show these three things. Okay, so now look at these two scenarios. If function is not continuous, on a particular interval, then we say that that function is discontinuous in that, at the point, the particular point. Okay. So look at these two examples. The first one is about we have drawn a piece of a function within an open interval a to b. Okay. So look at the point a to b open interval, and if you look at the point C, there you see there's a hole on the picture, right, on the curve. That means function is not defined. Function is not defined at that point. Okay, so if you look at the first, function is not defined, so I could not find the function value at C. It is not there on the curve because of the hole, right? Therefore this is does not exist. Okay, but but you see the limit value, right? Function has the limit value. When x approaches C, the function is approaching to where? Approaching to this value, right? If you look at your, or the y value of that particular point. So this is my limit value, okay? Say this is L. That means we have limit value, but function is not defined, right? That means if you look at those three, the first condition is not satisfied. Therefore, the first picture is, you know, the function which is discontinuous at C. Okay. Remember, I could redefine the function at that, at that particular point, right? If you redefine and putting some values for, at that particular point, and you are again remaking the function at that particular value in such a way that there's a value, right? So if you redefine function and if the function has the limit, then it is going to be continuous. So those kind of discontinuity point is called the removable. The removable point means you could make continuous. Okay. But keep in mind for the removable discontinuity, you have to have the limit value. There should be a real limit value. Otherwise, you cannot make, or which is a continuous. Okay. So now look at the second picture. It is of course obvious that function is not continuous at C. But if you look at the limit value, yes, limit value also not there, right? If you have limit value, you would have got same answer for both ends, from the right, from the left. But I'm getting two different y values for from the right and from the left. Therefore, if you look at the second picture, function at C is defined now. You know the value which is defined, where it is. It is simply here. You see the function value by dot, right? So function has the value now, but what is the limit of the function now? Now this is the thing. We don't have limit now. So this is now does not exist, right? Remember, in chapter in the first section 1.2 when we study about the limit. If you are asked to find the limit, that means what? That means right limit and left limit supposed to be equal. But now in this case, left limit is bigger than the right limit, therefore not equal. There's a difference between left limit and the right limit, therefore it is not, you know, it is not there for the limit, therefore it is does not exist. Whenever you have, you know, the limit is does not exist in this kind of scenario, will give you always non-removable discontinuity. Okay, so keep in mind those 2 points to identify what kind of discontinuity it is. Okay, now I already posted the completed version of our class notes just now, and you can go through, you know, to find out the solution here. Okay, let me ask one question here. Let's see who is telling. Could you tell me about the continuity of cosine graph? Do you remember the cosine graph?
Yes.
What kind of continuity it has?
Continuous.
Continuous? Where? Everywhere, right? So
Yes.
yes, if you draw the cosine graph is just a minute. So if you draw a cosine graph, this is my x value and this is my y value. Cosine graph will be like this, okay? It's going forever continuously, right? So cosine graph will be 1, cosine value 1 at 0 and 0 at pi over 2. So the cosine graph and sine graph as well, all are continuous throughout the real line. So this is continuous everywhere. Okay. What do you think about number 2? If you look at number 2, what will happen if I plug in x as a -1? What is the function value at -1? Could you evaluate that? No, I cannot find
No.
now, right? It is undefined, right?
Yes.
Why it is undefined? If you're plugging this -1 into your function, you will not get any real value, right? Because the denominator getting 0. What about the numerator? Numerator also getting 0. So you will have always 0 over 0 form. So it is indeterminate form. You don't find any real value, right? That means function is not defined. When function is not defined, of course, automatically it is going to be discontinuous at that point, -1. But now, what kind of discontinuity we have? To check whether it is a removable or, you know, non-removable, you need to check the limit value now, right? So I'm going to check the limit of function value where x approaches -1. Okay, so at this point we should be able to find the limits without any difficulty. Remember, when you have 0 over 0 form plugging the value, you need to use some techniques to find out the limit. In this problem, I could use a factoring technique, right? So let us factorize the numerator. This is nothing but difference of square. So 1 means 1 squared, right? So I forgot to put the limit here. So this is going to be limit x goes to -1. So if you factor the numerator, which is x minus 1 times x plus 1 over the denominator always x plus 1. So you could cancel these two. Now when you plug in -1, function limit value is -2. Yes, we have the real limit value. Therefore, it is going to be removable. Yes, discontinuity. Okay, so you have to identify like that in the problem. So why don't you think about number 1? So I already posted the solution, so make sure that you know, you understand. Okay, that's about discontinuities and continuity. Now here you see the one-sided limit. One-sided limit means here we are going to, you know, analyze the limit only from the one side, maybe from the left or maybe from the right. Okay, so suppose, you know, you look at the picture. Suppose if you want to find the limit of the function at the value z, if you approach from the right side, right? So you are approaching from the right side. Then we say that, you know, the one-sided limit, which is the right limit. That means x approaches c, but in the positive direction, this side. So you have to put the positive. So if you see here negative, that means we approach the function from the left side. That makes sense?
Yes.
Yes, very good. So now this is very, very important theorem. Let f be a function and let c be any real value. Okay. The limit of fx as x approaches c is L if and only if the right limit and the left limit of the function is getting again the same L. This means if you could write the limit when x goes to c of fx, which is L, if and only if both right and left limit, right, both of them have the same limit answer. That means this is if and only if. I use this notation for if and only if. You have to have, you know, the limit from the left of fx should be equals to the limit from the right of fx. That value also supposed to be L. So if this is the case, we say that limit exists. Okay. In another word, if you are asked to find the limit of like this problem, that means they mean that, you know, left and right limit are same. If it is not same, then there's no limit. Okay. Now, this is the definition of the continuity. A function f is continuous on the closed interval AB when f is continuous on the open interval. That means f should be continuous throughout this interval, right? At the endpoint as well. If you hear the endpoints, that means what? That means you know, suppose if I have 2 points A and B here, if you want to check from the closed interval, that means the function should be continuous from both ends. Okay. Remember, we are interested in this interval, right? We don't need anything outside of this interval. That means we don't care about the left side of A. We care only the right side of A, because the right side of A is the only region we have within the interval. So we are interested in this interval. Okay. Therefore, we need to check only the right limit of A and decide the left limit of B. That is why if you look at these two values, we only interest in right limit of A, that should be function value fa, and the left limit of B should be the function value of fb. So if you have these two conditions and the function is continuous inside the interval, that means function is continuous everywhere, including A and B. Okay. So if you look at the picture here, you see now two black dots. That means function is defined, right, at the endpoints. We know the function value at the endpoint. So you could draw the function graph without lifting your hand. Therefore, this function is continuous throughout the interval from A to B. Okay. Remember now, I'm writing here one more time. If function is continuous, it should satisfy three things. Okay. If function f is continuous on AB, right? That means if you have one point in this interval, say I have a point C, right? If the function is continuous at that point, that means the limit of that point, okay? So the axis and f of C is defined, and the limit of xc of fx should be equals to f of C. Okay, make sure that you understand again. Now you are going to tell me whether this function fx is continuous. If it is continuous, what is the interval fx that is continuous? Could you think about this problem? First of all, I'm giving one hint, okay? Could you check the points where function is defined? For which value of x this function is defined? Defined means what? You should have the real value if you're plugging x into this, this expression. Okay, what will happen if I plugging x as 2 into this function? Will you get any function value evaluating at 2?
1 minus 4.
Say it again. 1 minus 4.
Yes.
Yes, that means we have square root 1 minus 4. What is that? That is square root 3 negative, right? Can I find the square root for the negative number?
No.
No, that means you will not find any real number if the quantity, whatever we have the square root which is negative. You cannot have negative inside the square root, right? Therefore, you need to put the condition now. In order to define the function value, whatever we have the inside the square root, that should be a non-negative number, right? So I'm putting this condition. The function is defined only within this range of x. What does mean by that? So if you move x squared to another side, this is simply will tell you, hey, your x squared value is supposed to be less than 1. That means your x value should be between -1 and 1. Okay? That means what? That means your function is defined only for this range of x value. So your x cannot exceed, -1 this side and +1 as well. So your all the x values should be defined -1 to 1. So if you draw a real line, 0 is here, -1 is here, this is 1, this is my x values. So the domain of the function is now nothing but -1 to 1 inclusively. These 2 points are included. Okay. Right? Therefore, function is defined only for this value. Now, remember, whatever you plug in the x values within this range, you are always going to get, good number, positive number. Therefore, it is possible to find the real value in this range. Okay. So then note that the function value at the endpoints, could you tell me what is f of -1 and f of 1?
0.
0. In both ends, you will get 0. Very good. Therefore, function is defined, right? 0 is a real value. Therefore, function defined at the endpoint and inside as well. Okay? So remember, inside the square root, I have polynomial. Polynomial function is always continuous, right? Therefore, now inside the function of fx is now continuous everywhere within this interval. Therefore, f is continuous on -1 to 1 inclusively. If you draw a picture of that problem, you will get like this picture. Graph of fx will be like this. So that is a half circle. So this is -1. This is 1. Function value getting 0. So this should be 1. So this is the function of 1 minus x squared. So which is continuous. So you need to argue like that, and if it is possible, draw a picture. Okay. So this is about the first one. Okay. Now look at this picture and discuss the discontinuity. What do you see here? What are the points given here? Could you identify the points where function is discontinuous?
-3.
-3. Very good. That is one point. Is there anything else?
+2.
Very good. You see, there's a hole on the graph. Therefore, it is not continuous there. Very good. One more point.
1 or -1.
-1. You see now, if you see the dotted lines on the curve, that means which is an asymptote, right? The function is approaching to this line, x is equals -1, right? if you extend the curve at the infinity, the function will approach x negative 1. Therefore, negative 1 also going to be a discontinuity point. Okay, you see, if you look at the negative 3 points, let us argue one by one and analyzing. Okay, if you look at x negative 3 point, yes, function is discontinuous, but you see there's a jump between left and then the right end, right? There's a jump. So if you have such a continuity point, we call that as a jump discontinuity. Okay. Right? So that means that the limit of the function fx when x approaches negative 3 from the left is approximately somewhere here. Okay, so that is negative 0.8. But if you look at the right side of negative 3, which is here, that is around 0.7. Right? You see sudden increment here. That is why we call this as a jump discontinuity. Okay, so let's see who is telling. So now tell me, what is the limit of fx when x goes to negative 3?
That does not exist.
Exactly. If it is exists, you should have both and same answer, but we have two different answers. Therefore, this does not exist. Very good. You understood. Nice. Okay, so there is one point. What about at 2? What kind of discontinuity I have at 2?
Removable.
Exactly. Why it is removable? Because there's a limit answer. There's a limit value for the function at 2. Function is defined at 2, which is negative 1. You see here, right? Therefore, x is equals to is discontinuity but removable. Okay. So limit x goes to 2 of fx now exists, which is simply the y value of this whole, which is negative 0.5, right? But function evaluated at 2 is what? What is the function value? That is the dot value, which is negative 1. Yes. Okay. You see now, let me ask one question. I have to ask this because I need to make sure you understood the continuity, the notion. Okay. We have the limit at 2, which is negative 0.5. We have the function value at 2, which is negative 1. Then why we call this point, 2 is not continuous point, discontinuity point. Why it is discontinuity?
One-sided limit.
I did not talk about one-sided limit in these particular scenarios. I have only two. One is a limit value, another one is function value. Why we call this is not continuous? Remember I told you earlier, if the function is continuous, you have to have same answer for the limit and the function. Does that make sense?
Yes.
Now you see the limit value is negative 0.5, but the function evaluated at 2 is negative 1, two different values. That is why function is not continuous. You understand now?
Yes.
Yes, there are two conditions now satisfied in order to being a continuous, to function at the given point. You remember those three conditions we had at the beginning, very beginning today? You see, among these three, these two conditions are satisfied for that particular problem. But look at the last one. The limit value and the function value should be equal. This is the one we don't have now. That is why it is not continuous. You understand now?
Yes.
Yes, very good. This is kind of complicated, but once you get the idea, that's it. Very easy. Okay, so now these are the theoretical things. Now we are going to discuss about some, some basic functions for being a continuity. So all the polynomials are continuous function throughout the real line. Okay. The rational function means what? If you could write the function in terms of fraction p over q form, provided the denominator function is non-zero, then this kind of function is called a rational function, right? The radical function is nothing but whatever we have the radical, the notation. Maybe square root, maybe cubic root, and could be any positive number, okay? Then special cases about the trigonometric functions, sine, cosine, tangent, cotangent, secant, and cosecant, right? These all basic functions, okay? These all four scenarios, all four varieties functions are always continuous on their domain. Okay, if you see the trigonometric function, yes, sine is continuous throughout the real line, cosine also, but tangent is continuous where on its domain, right? For the remaining also as well. So make sure that you could go through your pre-cal and check whether it is satisfied all the continuous property, right? So just for your reference, and I could recall just the graph of tangent. Okay, so the graph of tangent has so many asymptotes. Remember, tangent has vertical asymptotes in infinitely many points, right? So 0 here, so this would be pi over 2, and this is pi, this is negative pi over 2, and this is pi. So if you draw the tangent, right, the tangent curve is, if you look at the tangent curve graph of tablet, so it's going. Does that make sense? So the
Yes.
the second piece is going to be like this. Go and check, right? And the third picture is again here you will have negative 3 pi over 2, right? Again, so this is the tangent graph. You see now, tangent has a lot of, continuity points. So remember, let's say who's telling what is the domain of the tangent graph? What is the domain of tangent x? Do you remember? What do you mean by domain? Domain of a function. The domain of a function is nothing but the points where function is defined, right? So at these points, pi over 2, negative pi over 2, negative 3 pi over 2, positive 3 pi over 2. That means, the tangent graph is, okay, tangent graph is undefined at these type of points. Where n is an odd number. For example, n could be any number plus or minus 1, plus or minus 3, plus or minus 5, right? So that means tangent graph is not defined at, right, at the odd multiples of pi over 2, right? That is why function is undefined at 3 pi over 2, it approaches infinity, and pi over 2, and negative pi over 2, and a negative 3 pi over 2. If you exclude those points, right? Except at those points, function is very good, always continuous. Therefore, the domain of tangent graph is all the real, right? All the real values, real number, all the real numbers except at n times 3 pi over 2, where n is a odd number, plus or minus 1, plus or minus 3. And if you are not sure about this, I just suggest you to go and check about, these things, because we should know the basic functions, properties and all, domain range and those things. And that should be easier for you guys. That makes sense?
Yes.
Okay. Do you have any questions so far?
I'm not trying to be offensive, but this whole section is confusing me beyond belief. I'm looking at the notes and everything. I'm trying to follow, but I just
Yeah, I know, I understand. So do you watch that videos from your website?
I actually have WebAssign pulled up right now. I'm
Yes, you
working
need
on.
to watch the videos to get the better understanding.
Yes, sir.
Yeah.
Dr. Raj, I'm actually kind of confused too, and I've been watching the videos and all on WebAssign, but I'm still just a little bit confused. There's just
Okay. What is the? Could you explain in particular at which point you get confused? Give one example.
I really don't know. I really can't think of a good example. I understood like the first two sets of homework. I don't know, just for this section, I just feel like I'm getting lost, I guess.
Okay. What about up to this point? Just now I explained this. So do you have any questions?
I really don't know what to say. It's like I understand half of what you're saying, and then I get lost. Like I understand like the domain of 10x and different things like that.
This is,
really,
yes, this is
yes.
not Cal 1, okay? This is not Cal 1.
Mm-hmm.
This
Yes,
is
sir.
all, yes, coming from your previous things, pre-Cal, college algebra, and those things, okay?
Yes, sir, and I do understand that. I understand
Yes.
all of this. So I understand like the basics of where
Right.
we're coming from. It's just whenever we begin to advance on into, I guess, the calculus aspect instead of the foundation and the basics.
Believe me, this is the thing now. So the thing is, you have to, work as much as possible problems, okay? Work really, really hard, okay? Because calculus 1 means so you have to, put more effort, right? So what my suggestion is, first watch the videos, okay? Then try to complete my notes. This is the notes I'm talking about, right? Just now I posted all the worked notes. So now if you look at 1.4, just simply read. I have, you see now, I already posted this. I have given all the answers like this, explained in detail.
Yes, sir. I'll go back over it again tonight more extensively. And
Exactly.
if I have any more questions, I'll email you tomorrow. Does that sound good?
Right.
Yes, sir.
Okay. Yeah, I understand. So it's not going to be easy, the calculus course. So we had to put on more effort. Okay.
Yes, sir.
Okay. Anything else?
Dr. Raj,
Yes.
there's a simple way of explaining continuity where people might understand is that the pencil test, where you
Okay.
follow the pencil, and if you have to take the pencil up, it's not continuous.
Yeah.
It's a
That's-
simple way of explaining that.
Yes, you're correct. So if you could draw the graph without lifting your hands, right? Okay.
So just a quick question before you start again. So with like, it's one of the first problems, but I'm trying to get started with understanding this. I can grasp based off of the pencil test of whoever just said that. I can understand the continuity or
Right.
of a line, but when it says as x approaches c, and then it'll have just a positive exponent or a negative exponent. I don't
Okay.
know what that means. Does that
Oh,
mean substitution or?
right. You are correct, because it depends on the problem. There are lots of different varieties of the problems, right?
Yes,
So
sir.
yeah, you're
Dr.
correct. Yes.
Dr. Raj, doesn't the plus or minus exponent, doesn't that mean as you approach it from the left would be a negative and as you approach it from the right would be positive? Isn't that what that means?
Yes.
So you mean, I believe you are talking about this notation, right?
Yes, sir.
Yes, you are correct. If you see minus sign, that means you are approaching from the left side. Okay. This is approaching from left.
But whenever you're approaching from the left and it asks for a numerical value as a answer,
Right.
what would be the answer of that?
Yeah. So I'm going to do some problems. I'm coming into that point within a minute. Okay.
Okay, yes, sir. I'm
Yeah,
sorry.
because no problem. I'm going to discuss our practice test problem. I have included so many, the kind of problems. Now you will see within a minute. Okay.
Yes,
So
sir. Yes, sir.
I'm just going over all the, the brief things, and after that we will come to that practice problems. Okay. This is very, very, very useful theorem, which is called intermediate value theorem. So we use short form of intermediate value theorem, IMVT. Okay. This is very basic concept, but if you put it into words, maybe a little bit confusing, but when you have a picture, it is very, very much understandable. If f is continuous on the closed interval AB, pretend that you could draw a picture without lifting your hand within this interval. For example, look at the given curve, right? So A is here, B is here. So yes, we have a continuous graph. If you have two, if you have two different function values at A and B, f of A is function value at A, f of B is function value of, at B. So if you look at the picture, A is here, so f of A is nothing but the function value, which is here, and f of B is here. If these two are different values, not equal means different values, right? Distinct values. And if k is any real value between f of A and f of B, that means if k is somewhere between, these two values, then there is at least one number C in AB. Then you could find at least one C. You may have more than one, maybe multiple C's, but at least you will find one C where in this interval A to B. Okay, such that function evaluated at that particular C value, which will give you, the in between function value, which is K. You understand this theorem? What do they say? Simply they say if the function is continuous between A and B, then always you could find one value C between A and B. You could find always one C in that interval, such that the function evaluated at that C will be equals to some values of K. This K is between f of A and f of B, right? So if you look at one example, that is easier to understand. Look at this one. So that the function fx has the real root, 0 means root, in the interval. Okay, you are given a function fx. So you need to show that there is a solution for this equation. In other words, we could find one real value x for this function. Okay, so simply use that intermediate value theorem. If you want to use the intermediate value theorem, first of all, you need to check that function is continuous on the given interval. Look at the problem. Function is this polynomial function. Just now I told you polynomial function is continuous everywhere. Therefore, this function is continuous within this interval as well. Okay, so f is continuous on the closed interval 0 to 1. Okay, so that means what I'm trying to say is this is x, this is y. So if you could draw a picture like that, now this is the curve of my fx. Fx is, you know, polynomial continuous. Now if you look at the interval, okay, so my graph may be accurate. I'm just drawing, you know, arbitrarily to explain. Okay, so what are the challenge? They say that if you could find two values, so this is my a now according to the theorem, this is my b. I'm always comparing with the theorem here. So f is now the given function, so our f is x cube plus 2x minus 1. So a and b are two values. So in this problem, a is 0 and b is 1. Okay, so now we need to check this condition. The function a value and function b value should not be equal. Could you check that? F of 0, simply plugging 0 into your function, which is -1. And what is f of 1? My b is, this is my f of a. Okay, my a is now 0. So now what is f of b? My b is now 1. So if you plug in 1 into this formula, you will get 1 plus 2 times 1, which is 2 minus 1, which is 2. Yes, these two are different values. Therefore, the condition is now satisfied. Therefore, we could apply. So two conditions are now satisfied. What are those conditions? Function is continuous and f of a is not equals to f of b. If these two conditions are satisfied, that means we could apply that IMBT theorem. Okay, IMBT says what? We could find always one c value where in that given interval 0, 1, right? Such that f of c, which is equals to k, right? What is k here? K is a number between f of a and f of b. Okay. So in this particular problem, our f of a is, just now we calculated, -1, right? So our k should be between -1 and f of b is +2. Theorem now says that you could find always one c value between 0 to 1 such that if you're plugging that value into your function, it will give you some k value. That k is now between -1 to 2. Okay. Now what do you want to show actually? You have to show that this, you know, function has the root. What does mean by root? Root means if you're plugging any particular x value, that should satisfy this equation. That is the meaning, right? What is the meaning of solving an equation? Simply, you need to find the x value such that that will give you 0. That is the meaning of solving an equation, right? You have to put the 0 here. You understand? So now we need to show that there is a solution for this problem. Yes, I could write now there is a value c such that my k could be 0. Why may my k could be 0? Because your k is any value between -1 to 2. Yes, of course, 0 is a number which is -1 in between -1 and 2, right? Therefore, I could pick my k as 0. No harm, right? Your k only should satisfy this range. You could pick any k value in this range, right? If you want to show something is a root of the given problem, that means you have to simply show that that root satisfy your equation fx is 0. Remember solving quadratic equation? Do you remember? You write the quadratic expression, for example, you write 2x squared minus x minus 1, you put equal 0 here, remember? to solve the quadratic equation. So if you want to solve some equation, you have to have 0 here. In simple way now, here, we write that function as now my fx. So I'm putting 0. Okay. So please watch the video for this and tell me if you have a, or the problem persists still. But I understand this is not easy to, get. But anyway, please watch the video again and again and get the concept of intermediate value theorem. Okay. So you may be asked to find some C value. In this particular problem, you don't need to find C. You need to show only that there's a value, there's a root. Okay. So again, answer is there in my solution, work, the class note. So you will find out everything. Okay.
Dr. Raj, so
Mhm.
what specifically is the answer for this problem?
The answer is you have to show that this.
All right, thank you.
Right. That means what? I'm trying to say that there's a solution root for this problem, which is little c. Right. So if you find the root of this given problem, you will find out one answer, one solution. That solution is between 0 to 1. But you don't need to find the solution. You need to just show that there's a solution. Okay. So for that reason, so you try to read this one. For example, I'm leaving this. So check whether you understand this one. Okay. So again, you could work on art problems if you want from your textbook, because you have the answer for work, the art problem. Right? Okay. So let me go very quickly 1.5, then we will do some problem. 1.5 is nothing but finding the limit that is infinite, right? So your answer is always infinity. Big answer, infinity means very big number, right? So remember in previous section, we were finding the limit which are real value, right? If you do not see any real value, then we say that does not exist. That is the another way of, explaining, if you have the limit, which is a very big number, which is we call the infinite limits. Okay. So infinite limit is nothing but your function is getting big value when x approaches to some real value c. Okay. So in notation wise, we use this. You are given a function. If you're plugging that x, the c value, you have to get the infinity value, which is called the infinite limits. So we will look at some example very quickly. Look at this. When you plugging -2 into this function, what you will get? You will get simply -4 over -2 plus 2, right? So that is -4 over 0. When you see 0 in the denominator, then answer is always going to be the infinitive, provided the numerator is supposed to be non-zero. Okay. If you have such a scenarios, numerator is non-zero, but the denominator is 0, then this will give you always positive or negative infinity. That depends on the sign we have in front of the the problem. Here I have negative sign, therefore you get the negative infinity. Okay. So the negative infinity means what? Very big number, but in negative sign. Negative big number, in another word. That's
So
why
with this, what would normally be considered undefined is now negative infinity.
right. Well, there are two different scenarios for undefined. Okay. So undefined, one case of undefined is infinity. There is another case. There are two cases. This is one of that, right? What will happen if what is that example I could think of? Okay, so I will get that after doing some exercise
Yes, sir.
problem.
Yes, sir.
Yeah, I don't want to confuse at this point. Okay.
Yes, sir.
Right. So But technically, if you see the denominator piece is 0 with the numerator non-zero, then you will get always what? Infinity. Okay. Now, okay, come to this problem. Okay, now you have left-right limits. Confusing, no? Okay, so now let's see whether you understand this one. What is the meaning of this expression? Could you explain in words?
It's undefined and the numerator is negative, so it makes negative infinity.
So what's happening? From which side, the x value is approaching?
From the
Which-
right.
From the right, yes. So -2 is here from the real line. Now x approaches from the right. Okay. So you could think of like this, that x may be very close to -2, but coming from the right side. Okay. That means you could think of the very close x value, to -2 from the right is -1.99999. You could think of like this, right? Understand?
Not entirely. So it doesn't cross 2, but it comes right next to it.
Exactly. Very close to -2 from the right.
Okay.
It's not crossing -2. You are correct.
Okay.
Right?
Yes, sir.
So that's the meaning. Okay, so now what will happen if you plugging? You could think of like this. That's what I'm trying to, tell you. So now, what is my task? My task is to plug in, not -2, -2 from the right side, right? They're asking us to find one-sided limit. So you have to, plugging some possible x only from one side. Which side now for this problem? From the right side. Okay. What I used to think is like this. Okay, you see now I'm just, for example, picking very close number to -2. That is -1.99. Does that make sense?
Yes, sir.
Okay, if you plugging that value into x, what kind of sign you will get? Suppose if you're plugging here -1.9999, because this is very close to -2, but little bit bigger, right? So then what kind of sign you will get once you, simplify everything in the denominator? Could you tell me what is it, the negative number or positive number? If you're plugging
Positive.
x, positive, very good. Because your x is very close to -2, but never crosses -2. Therefore, once you're plugging that number here, that x is, little bit bigger than -2, somewhere here. So ultimately you will get one positive answer, but that answer is very close to 0. Am I right? Simply take your calculator and plugging these two values. -1.999 plus 2. What's the answer you get?
I got -40,000.
No. I'm asking only the denominator. Don't confuse with the numerator. Just I need only the denominator piece, x plus 2. Just plugging into x plus 2. What is x plus 2 here? If x is -1.999.
0.0001.
That's what I wanted. 0.0001. Right? This is very close to 0. Am I right?
Yes, sir.
But in the positive sense.
Okay.
What does mean by that? That means this answer is very close to 0, but positive number. That's the meaning. Did you get that?
Yes, sir. So it's still a non-zero number.
Non-zero number, but very close to 0. Very,
Okay.
very close to 0, but positive 0. That's what I'm trying to explain.
Yes, sir.
Right? Okay. So you could think of now approximately the denominator is very close to 0. Am I right?
Yes, sir.
Then now tell me, what is 4 over 0? 4 over 0, any number over 0, which is infinity, am I right?
Yes, sir. Negative infinity or
Negative infinity. Negative infinity, because you have the negative sign in front of 4. Therefore, the answer is ultimately negative infinity. that make sense? I'm writing here. You are dividing by 0, but -4. Forget
Yes,
about negative sign for time being. If you do not have negative sign here, 4/0, which is, you will say infinity, right?
yes, sir.
But what kind of infinity I have? Because I have negative sign here, you just plugging that sign.
Yes, sir.
So, which is negative infinity. Yes, correct. Now move to the left side of -2. Now let me draw the pictures. One more picture. You are very close, to understand. Then once you understand, that's it. You will never forget one side limit, okay? Right, now where you approach? From the left or from the right for the second piece?
From the
You
left.
see, from the left, you see the negative sign. Now you are approaching from the left, very close to -2, but from the left. So, what is the possible number I could pick very close to -2 from the left? You could think of -2 point. I may say 1, right?
Yes, sir.
Do you see everyone? Or if you want much closer to -2, I could pick 2.0001. That's also correct, right?
Yes, sir.
Okay. Now, plugging this value for x. So now, I am going to look at this value, right? Again, like earlier. But now, my possible very close x is -2.0001, but plus 2. Now look at the denominator. What kind of sign you will get now? Take your calculator and plug in those two values. -2.0001 plus 2.
Negative.
Negative.
Now you are getting negative sign. Very good. The denominator getting now negative sign. But very close to 0, right? This is 0, but negative sense. So I put like that. That makes sense?
Okay.
0, but very close to negative. So now tell me, I have -4 in the numerator, but the denominator is very close to 0, but negative number, right? Now what you'll get? Negative over negative will make positive, right?
Yes.
4/0, what is that?
Infinity.
Infinity.
What? Quick question. Okay, so is it called negative because you can put any number in the x that is, as long as it doesn't go to, like in that case it was 2, so you can put as many like 2.1111
Whatever you like, yes. Any number, just, after -2 in the left side, you could put any number. I choose this one. If you want, you could choose 2.111, 2.222,
Okay.
2.555 negative, whatever you could pick for x. Doesn't matter. Right? But I'm
Alright.
picking in such a way that which is very close to -2 because I need to find the limit value, right?
Yes, sir.
So ultimately, what you want to look at is just look at the sign. What kind of sign you are getting in the denominator. But anyway, we know the answer is going to be 0 if you're plugging -2, right? Simply if you're plugging -2 without any sign, I know that denominator is going to be 0, right?
Yes, sir.
But what kind of 0? Is that positive side 0 or negative side 0? To check that, you have to look at the one-sided limit. You understand now? Okay, so we got now two different answers, am I right? From the right side, you got negative infinity. From the left side, you got positive infinity. These two are different values, am I right? Two different values. Okay, therefore, what do you think about x goes to -2 of, let's see who's telling. What is the limit answer of this? I don't put any one side. I need just -2. What do you think?
Couldn't you just put like positive, negative, infinity so you can have like both?
You need to have only one answer.
Does not exist.
Does not exist. Why it is does not exist? Because you got the left limit and right limit, two different answers. Remember the limit definition, very first section we learned, 1.2. If you have the limit value of the particular point, you have to have left and right limit same. But I don't get same now because the right value is negative infinity, left value is positive infinity, two different guys. So therefore, this answer does not exist. Only I have the left limit and the right limit. Let me explain this by drawing a picture, okay? Agreed here? Everyone? You see, right?
Yes.
Okay, I'm going to draw now graph of -4 over, what was that problem? X plus 2, right? What kind of graph now I'm getting? Look at the curve. Do you see the curve now? This is the graph I'm drawing for the
Yes.
given problem. When x approaches -2, you see now you have now vertical asymptote. Do you see that? Function is not continuous at -2. If you move from your left side of -2, function is going all the way to positive infinity. If you move right side of -2, your function is going all the way down negative infinity. Do you see now in picture? Say yes or no.
Yes.
You see, this is the another way to check your the one-sided limit by looking at the curve. Again, I will take more examples today. You will see they are in practice test. Okay. So at this point, I just move back here. Okay. So let me finish first this all the things, then we will look at the examples. Okay. Now, do you remember about the vertical asymptotes? Have you studied this here before?
Yes, sir.
Yes, you might have seen this in pre-cal, right? Vertical asymptotes means what? If you draw a graph, the graph never touch that axis, the vertical axis, vertical line. It should approach along that. It cannot cross that line. If you draw a picture, picture should be like this. If you have such a line, vertical line, that is called the vertical asymptotes. How do you find the vertical asymptotes for the given function? Simply find the points where function getting infinity, maybe positive or maybe negative. Okay. So if the graph of the function has the vertical asymptotes at the given point C, then that function should be not continuous there because function cannot, meet at that point. So it's going all the way. So function will be discontinuous at that particular point. Okay. How do you identify vertical asymptotes? Simply look for the points, look for the x values where the denominator getting 0. Simply look for the denominator 0, provided numerator is non-zero. Okay? Like a limit giving infinity value, you could think of like this. So if you look at this problem, what is the vertical asymptote of this problem? Well, this is the given function. Simply look at the denominator and tell me for which value of x denominator getting 0.
-1/2.
-1. -1. If x is -1, your denominator is getting 0. So you look for those kind of points. So this is the line when you draw a picture, right? When you draw the curve, oh, it is given here. Look at the curve. The curve, right, has the discontinuity at -1, right? There are two pieces of the graph. So when x approaches from the right to the -1, function getting positive infinity. When x approaches to -1 from the left, function is going down negative infinity. So we got two different values, therefore function is not continuous, which is clear in the picture. Do you see that? So now this kind of line is called vertical asymptote. So in this problem, x is -1 is the line, vertical line. So is an asymptote. Okay. Look for the points where denominator getting 0. Okay. Now, if you are given like this, how do you find the vertical asymptotes? You need to simplify as much as possible, right? You have to use the techniques. Remember, you could factorize this denominator. X squared minus 1 could be written as x minus 1 into x plus 1. Now look for the denominator where you are getting 0. In other words, what are the x values you are getting 0 in the denominator? When x is
1
1,
Negative 1.
1 and negative 1. Therefore, these two lines are going to be now vertical asymptotes for the given problem. In another word, function will approach negative or positive infinity along these two lines. So if you look at that curve, it is here, right? So negative 1 is here, positive 1 is here. So these two are the vertical asymptotes. You see now function is getting positive infinity from the right side of 1, negative infinity from the left side of 1. Function is getting negative infinity from the right side of negative 1 and the positive infinity of left side of negative 1. So these two are the vertical asymptotes. So why don't you go through these all notes and get rid of all the doubts. Okay, right. So now I have a couple of problems to work on today. So have we gone through the practice test?
Yes.
Okay, let's see very quickly. Now, I think the first problem should not be harder for you guys. You will say very easily. Okay, tell me, what is the answer of first limit?
Negative 1.
Okay, no confusion. Here we don't talk about one side. Do you see minus plus in exponent? No, right? So these all just a limit. Just a limit. That means what? You need to have right side and left side limits should be same. If you have different values, does not exist. So when x approaches 3, where's 3? Okay, 3. You have to find the limit value, so you have to look at the curve here. Yes, which is negative 1. Do you see that? Say yes or no.
Yes.
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 Good. What is next one? Function is approaching to 1.
Does not exist.
Why it is does not exist? Why? What's the reason?
It's a break.
It's a break.
Huge break in the graph.
That is 1. Or you see now you are looking at 1, right? Because the right side approaching is positive 1. From the left side approaching is negative 1. Two different values cannot have. You have to have same value to have a limit value. That is why left and right limits are different. So therefore no limit answer does not exist. That makes sense?
So
Yes.
there was a line that continued off of that
Yes.
as it approaches.
You are correct. Yes. There should be a continuous graph and you should have only one hole on their graph, right?
Okay.
Yes. There should not be any jump or, things. Okay. X approaches negative 2. What's happening? What do you think?
Does not exist.
Yeah, it's an asymptote.
That means one is
Does
going
not.
positive, yes. Left answer going positive infinity, right limit is going negative infinity. Two different answer. Again, does not exist.
Okay.
Why it is? Because left side is positive infinity, right side is negative infinity. You can't have two different values. That's why. Okay, limit x goes to 5 of fx.
It doesn't have one because it has two values.
Again, does not exist. That makes sense? 5 is here, right? So from the left is 1, from the right is 3, two different values. So it is impossible. So that's not harder. Okay. The second one, just simply plugging the values. What is the limit value? Easy. 2 times 2 minus 1, which is
3.
3. Very easy. But the second part, you have to use the epsilon delta definition to prove that above result, the answer you got. Okay, what do you want to prove? You need to prove that the limit x goes to 2 of 2x minus 1. What is the answer you got? 3. So you have to prove this by using what? Epsilon delta definition. Remember in the lecture notes, that's a procedure always we follow, right? So I already posted the answer in detail. First, look at your note, okay, and video about what? About epsilon delta definition, okay? Once you understand, then come back and check my answer solutions, and I have given everything in detail explained. So this should be good. I don't want to waste the time on this, okay? That makes sense?
Yes, sir.
Yes.
I need to cover today these kind of problems, limiting. Okay, so remember, the first one is very simple. If you are given polynomial, radical functions, trig functions, and all, simply plugging the values and check. If you get the real value, you are good. If you are not getting, good form, say you are getting indeterminate form like 0 over 0, then you have to look at some techniques, right? Okay, let's go through very quickly. The first one is very simple. Simply plugging -1 into your polynomial. -1 squared minus 2 times -1 plus 3. What's the answer?
1.
-1 squared is +1. Here +2, which is +3 plus 3, 6. Okay, good. The second one is inside the square root, you have to have a good number, positive number. Otherwise, the limit does not exist. So now I'm just plugging 1 inside. So 1 cube minus 1. Remember, I have the square root sign. So 2 minus 1, 1. Square root 1, which is 1, right?
Yes.
Easy. Next one. You remember, sine graph is continuous throughout the real line. So no problem, no harm. You will have always limit answer. So simply plugging pi instead of x. Then what you'll get? Sine pi times pi, right? Which is pi squared over 3, right? Say yes or no.
Oh, yeah. Okay. Okay.
No confusion. You need to multiply here, pi times pi, right?
Yes, sir.
That is pi squared. So I know some students may think like this. This is different. No confusion. This is, you see, I am putting, this is different. These two are different things. No confusion, okay? What does mean by the first one? First one is simply sine pi over 3, then square. What is sine pi over 3? Let's see who's telling. What is sine pi over 3?
Sine pi over 3.
Unit circle. At this
Square
point,
root
you
of
have
3 over 2.
square root 3 over 2. But you have the square outside. So this is the meaning of the first expression. But the second one is not like that. Remember, square is inside the sign, okay? So you will get some decimal number, no confusion. These two are different things. So you could leave the answer like that. No need to simplify. If you want, you could use the calculator and put the values. Sine, put the parenthesis. Inside the parenthesis, you should have pi squared over 3. No confusion, okay? So the first one is not there. That is not there. This is not correct. For our answer is different. Okay?
So you just leave it in that form?
Yes, leave in that form.
Yes, sir.
Because we don't know, good number is not there. You will get some decimal points.
Yes, sir.
Okay, I don't want to approximate. I need the exact answer.
Yes, sir.
Okay, next one. Simply plugging pi over 4 instead of x. So you will get tangent 3 times instead of x, simply plugging pi over 4, right? Now this is tangent 3 pi over 4. Let's see who is telling pre-cal. What is tangent 3 pi over 4?
-1.
Very good. That is -1. Okay. So you could use the calculator again, I'm telling you, or look at the unit circle. Oh, now number 5. That is now giving trouble. Why? If you plugging 0 right away, you will get 0/0, right? You see that?
Yes.
Now you are in trouble. Then you have to use now some kind of techniques to do this problem. So the common technique we use is factoring. Okay. So check whether you could factorize this numerator. Yes, I could factorize the numerator, right? You see now, x is the common factor between, 2x squared and x. So I am pulling x as a common factor. So you should get 2x minus 1. Do you see that?
Yes, sir.
Okay. The denominator itself, you have x. Now, here and there you have x. You could cancel x if you have multiply sign in between two, quantity. Yes, I have multiply sign between x and the parentheses. Therefore, I am good to cancel these two. Gone. Now plugging 0 in place of x for the remaining one. Easy. Now if you're plugging 0 here, what you'll get?
-1.
-1. That's it. So the limit answer is -1. Good. Okay, again, number 6, giving trouble. If you're plugging -1 right away, you get again 0/0, right? Okay, do you remember how to factorize a cube plus b cube? Okay, recall high school. How do you factorize a squared minus b squared? Difference of square, how do you factor? A minus b times a plus b. Do you remember?
Okay.
If you factorize a cube plus b cube, which is a plus b times a squared minus ab plus b squared, you can write down somewhere else today. You are going to learn a lot of basic things like this. I may give, time to time like these. So this is the easiest things you have to memorize. So if you have cube with a plus sign, always put the AB first with the plus sign, whatever you have in the problem. Then put the first term square. If you have plus sign, alternate the sign, put the minus. Then multiply these two. Then put the square. Last term is always plus. If you have negative sign between a cube and b cube, then plugging AB and put the negative sign, then first term squared. Now switch the sign. If you have minus, then make it plus. AB and b squared. Okay. Now if you look at number 6 problem, let me write down somewhere here. I am going to factorize the numerator piece, x cube plus 1. X cube plus 1 could be written as x cube plus 1 cube. Am I right? 1 could be written as 1 cube, right? Now, this is the form of a cube plus b cube. Do you see that? Our a is now x and b is just 1. If you're plugging AB into your formula for a cube plus b cube, you will get the factorization of a cube plus b cube. My a is now x, simply plugging x here, and my b is 1. So you will get what? X cube plus 1 cube is nothing but x plus 1 times first term squared, which is x squared. If we have plus minus, multiply these two. 1 times x is simply x. Then plus the last term squared, which is 1. So this is the factorization of x cube plus 1. Do you understand?
Can you do that just because it's a 1 in the numerator, or can you do that if it was like a 2 or a 3?
You could do for any number, no problem.
Okay.
Yeah, that's why I have formula for any number a and b.
Yes, sir.
Okay, good. Now look at the problem. My problem was what? Finding the limit. Now I am getting into my original problem. Problem was finding the limit of this Now I know how to factor the numerator piece by looking at my answer here. So this is limit x goes to -1. Okay. So instead of the numerator x cubed plus 1, I could replace that by my factorization answer, which is x plus 1 times x squared minus, oh, there's no 2, minus x plus 1, then this all over x plus 1. Okay. What I'm doing here, simply replacing x cubed plus 1 by x plus 1 times x squared minus x plus 1. Now these two gone, you will get simply limit x goes to -1 of x squared minus x plus 1. Now it is very simple to plugging the values. Simply plugging -1 here, you will get -1 squared minus -1 plus 1. So that is 1 plus 1 plus 1, which is 3. Do you
Okay.
see that? So everyone, are you following me or not?
Got it.
Yes, yes, sir.
Yes, yes, yeah. You see now, this is the catch. You are going to apply a lot of basic things into Cal 1. That is why you are, the basic fundamentals should be very, very strong, right? So make sure that you refresh all the, you can just go through very fast all the high school math formulas, whatever you learned, and the pre-Cal, college algebra, those things. And you should be good. A lot of formulas only we need. Okay. So that is there. Good. The next one, first plugging the value -2. What will happen -2? If it is x -2, then numerator is, what is the numerator if you're plugging -2? Could you check?
Could you repeat that, sir? I'm sorry.
Could you plugging -2 into that numerator piece? What you'll get? I'm talking about problem number 7. I need to check how much we are getting for the numerator if x is -2. So that is the 3 times -2 squared is 4, right? Are you getting good number? No, we are in trouble. You are getting 0. Am I right? When you're plugging -2 into the numerator piece, you are getting 0. The denominator also 0. So again, you are getting 0 over 0 form. Am I right?
Yes, sir.
Okay, then again, you
Yes,
have
sir.
to use the technique, either factoring or long division. You could go for the long division if you know the long division for the algebraic expressions. Or for the rational function, you could use, the long division. Okay. Or if you know the factoring, could you factor that, the numerator piece? Let's see who's telling. Could you factor that? Factoring is always easier. Could you factor this? So if you factor, you should get here 3x and here x. And here, I believe you should get 2 and here you should get 1. Am I right? So recall the factorization you learned. Okay. So limit x minus x goes to -2. So my numerator after factoring, it's going to be 3x plus 1 times x plus 2. But my denominator already have, the x plus 2. So now these two gone. So now simply plugging -2 into that problem, which is 3 times -2 plus 1. Okay. Which is -5, right?
Yes, sir.
Okay. But number 8 is not that much easy because you see the radical. I need more space for number 8. Limit x goes to 3 of x plus 1 inside the radical, -2 is outside, over x minus 3. If you plug in 3 right away into this rational function, what you'll get, if you plug in 3 here inside the radical, you get 3 plus 1, which is 4. So square root 4 is 2. 2 minus 2, you will get 0 in the numerator. But what about the denominator? Again, it is getting 0. So we are in trouble now again, 0 over 0 form. So you need to use some technique. Now, unfortunately, you can't use the factoring or the long division procedure techniques because you have the radical sign here. Okay, so if you see the radical in either denominator or the numerator, we use this kind of technique, which is called the multiple of conjugate. Do you know about conjugate function?
Yes.
So you need to multiply, the radical with its conjugate. So with the plus sign, right? We see if you have minus here, you have to make it plus. That is called the conjugate of the, the rational expression. So if you rewrite the given problem, so I'm simply writing my numerator, x plus 1 minus 2, putting into one parenthesis, x minus 3 over there in denominator. Now I'm going to multiply my numerator by its conjugate because I see the radical in the numerator. So simply multiply, but with the positive 2. Whatever you multiply with the numerator should be multiplied with the denominator as well. Why? In order to make the fraction equivalent. Okay. Now, do you know how to multiply two expressions with conjugate with each other? You need to distribute. You need to distribute and simplify it. Okay. If you are very smart, you could compare this always with the difference of square, the factoring. Just now I wrote you. Oh, I erased. Remember, I just wrote down this formula, right? A squared minus b squared is a minus b times a plus b, right? That means what? If you multiply the expression with its conjugate, then you will get the first expression squared minus the second expression squared. The same thing happening here, right? So you could think of this as like A, and this is like B. A, and this is like B. 2 is like B. So if this is the case, this expression is simply A minus B times A plus B. So A minus B times A plus B is simply A squared minus B squared. So if you rewrite the numerator, simply A is now square root x plus 1, but A squared minus my B is 2. So simply 2 squared. Okay. Or if you are not seeing this, if you feel difficult, you just distribute. You know how to multiply two, rational functions, right? Do you know how to multiply? I'm using the short form. A minus b times a plus b is nothing but a squared minus b squared. My a is here square root x plus 1 and my b is 2. Okay. Now only thing is we need to simplify. Let us simplify. If you square with any square root, what is the answer you will get? Simply square root will be get rid of, right? Then what I'm trying to say is square root x plus 1 whole thing squared is nothing but x plus 1. Then 2 squared is 4. So that is the numerator. The denominator is x minus 3 times square root x plus 1 plus 2. Okay. Now if you simplify further, the numerator will be simply x minus 3. Do you see that?
Yes.
That is why we multiply with its conjugate to cancel that denominator x minus 3. He is the troublemaker. So I need to get rid of that guy. That means now problem is very easy. X goes to 3 Nothing is there in my numerator. That means just 1 over x plus 1 plus 2. Now simply plugging the value, you will get what? If x goes to 3, you will get 1 over square root 3 plus 1 plus 2. That is square root 4 is 2, 2 plus 2 is 4. You see that? We have more work, right, in this problem. Anyway, I have already posted the solutions and you will go through. Okay, does that make sense?
Yes.
Yes.
Oh, okay, good, good. Right, for the number 9 and 10, you have to use that property. Remember, the trigonometric properties that is in 1.3, I believe. So go back and check your 1.3 lecture notes. There we had, I need to clear this. Let me clear this. Okay, I need the space under this problem. Okay, so recall 1.3. From 1.3, do you remember we have trigonometry limits there in your note? Limit x goes to 0, sine x over x. Do you remember the answer of this? This is one standard theorem we had. If you find the limit of sine x over x, x goes to 0, what is that?
1.
Always 1. Very good. Then one more thing you had. Limit x goes to 0 of 1 minus cosine x over x, which is
0.
0. These two are there in your, the class note 1.3. So you could use these two properties to do remaining two problems, right? Remember, you have to be very careful. The sine x over x means you have to have same value in sine function and the denominator, okay? If you do not have that, you have to make it. So now look at the first problem. You could pull the constant multiplication inside the function. If you have, you could pull that out in front of the limit, right? So remember, 2 is nothing but multiplying with the denominator. So you could rewrite this as how? You could rewrite inside function this as half times sine t over t. Now remember, half is a multiplication of a multiple of this expression. Therefore, remember the limit property. If you have the multiple constant with the function, you could put that constant in front of the limit. That is half of the limit of sine t over t goes to 0. Now you could apply the theorem. So only thing is, instead of x now we have t. Doesn't matter, right? The function value going with the same value. So sine t over t goes to 0 is equivalent to have a limit x goes to 0 over sine x over x. You may have any variable name here, but answer is always going to be 1. So which is 1/2. Okay. But to do the second one, you have some you have to play around a little bit to get into that second format. So what I'm going to do is I'm going to write down the given problem into two pieces. First, I'm going to combine x and 1 in order to get the the expression in the second. So I'm rewriting the given expression into two big terms: cosine t minus 1 over 3t and minus sine t over 3t. Remember, you could split into like this. If you have the combined version of rational functions, always, could be decomposed into two rational functions with the same, the denominator. Okay. Now, again, the limit properties. If you have plus or minus sign inside the function, you could put the limit and distribute separately. So this is limit t goes to 0 of cosine t minus 1 over 3t, then subtract limit t goes to 0 of sine t over 3t. Okay, so I need more space here. Okay, so now you need to find these two limits separately. Okay, the first limit is now you need to rearrange that into, you know, the properties form. So that could be written as, the first expression could be written as 1/3 negative. Do you see this? If I write like that, do you agree with me? The first piece, I am pulling negative sign as a common factor. That means I need to switch the numerator, cosine and 1. Then I am pulling 3 in front of the problem, 1/3. So that is there. Now the second one, again, I am pulling 1/3. Like earlier we did, like earlier problem we did, sine t over t, right? Okay. So now I'm going to again plugging, you know, pull the constant negative 1/3 outside the limit. Limit t goes to 0 of 1 minus cosine t over t. Then minus, again pull 1/3 from this limit. Limit t goes to 0 of sine t over t. Now you know the answer of this piece. What is this? By looking at the property here, this is going to be what?
0.
0, because the same thing you have here, only the variable name is different, so it is 0. Then again, the second expression here, sine t over t, which is just 1. So that is going to be 0. So you will get negative 1/3 times 1, which is negative 1/3. Do you check my answer now, guys? I already posted, right?
Yes, sir.
Yeah. So if there is a different from my answer, please let me know. Okay. So at, up to this point, I believe all of you are getting right. Okay. For number 4, again, I already worked out, and you should be good. Do I need to explain number 4 now, or it is understandable?
I can look back at it, but I've done that one before.
Yeah, it is easy. So if you have done already, you know, that web design, this should be easy. So try to finish the web design problems. Then, so I will write down the first couple of steps for that problem. You are given fx. You are given the function. The thing is now you need to find the limit of delta x goes to 0 of the function f of x plus delta x, subtract fx over delta x. Okay, simply what you want to do is you have to find you know, two different things. First, find f of x plus delta x. You already know f of x, right? So f of x is given. Then how do you find f of x plus delta x? If you compare these two, in place of x, here you have x plus delta x. That means to get f of x plus delta x, simply take the function of fx, replace x by x plus delta x there. Then you will get f of x plus delta x, right? So simply replace x by x plus delta x in fx function to get f of x plus delta x. Okay. So find out first f of x plus delta x then. So f of x plus delta x is, I'm taking my f function, that is 1 over, in place of x, now I'm replacing x plus delta x, but I have subtract 1. So this is my f of x delta x. Now you need to subtract this f of x plus delta x, right? So you need to subtract fx from that. So now find out this guy. You need to find out first this one. That is simply find out f of x plus delta x, that is this, right? Then subtract f of x. F of x is there, the original function. Oops, That is my original function. Now, only thing is you need to subtract two fractions. How do you subtract two fractions? Well, you need to find the common denominator, LCM. So LCM of this problem is x times delta x minus 1 times x minus 1. Now do some algebra and plug in these values. And I already explained this, clearly in my solution sheet. Okay, then you should be good. After simplifying this guy, after that you need to divide by delta x and put in the limits. You will get the answer. So that is there for number 4. Okay. Oh, now number 5 is about one-sided limit. Let's say you are telling answer or not. Let's look at number 5. Tell me the answer.
2.
You are approaching to -1 from the left. -1 is here, but from the left, that means function is here from the left piece. Yeah, you are approaching the function value 2. Very good. So it is 2. If you do not see it, please let me know. I will explain one more time. Okay, what about next one? What is the function value? You are approaching -1 from the right.
Zero.
Very good. Now look at -1 is here. You are approaching from the right. That means you have to go along the curve. Curve is approaching function value, right? That is 0. Function value is y value. That is 0. Yes, good. Now, okay, what is the next one then? What is the limit of x goes to -1?
Does not exist.
Does not exist because right limit and the left limit are two different answers. In another word, if you look at the picture, there's a big gap. You cannot have gap to
Yes, sir.
find the limit. Yes, therefore does not exist. Very good. What about the last one? What is f of -1? What is the function value of -1? Function value means it should be defined, right? The bold dot, dark dot is a function value. What is the
That's
function
0.
value? Again, 0.
0.
Yes. Okay, that makes sense. This is, number 6 is the typical problem you always come across. This is kind of step functions. There are two different functions given, right? If you look at the first piece of the function, this is a parabola, right? Quadratic function. The second one is linear function, right? The question is, this is just roughly I'm telling you, right? I don't know exact graph. If you draw the first piece is, minimum curve. You know how to draw the parabola, right? So this should go, I don't know. So if you draw correctly, it should go somewhere here, -1. So that is like this, the first graph, if you draw correctly. But remember, you need to draw the quadratic. The parabola piece is only for the x less than 1. What will happen if x is 1? If you plug in 1 here, you will get the function value at 1. If x is 1, you will get 2 minus 1, which is 1. So if x is 1, you should get 1. Positive 1, right? So function will be 1, will be somewhere. That means what they are trying to say is, hey, draw only the parabola quadratic piece only for x less than 1. So you don't need to draw this piece. So you have to erase. Okay. So I don't know how to, will it be going? Oh, everything gone. So you need to draw the picture only up to the 1. But this side you could draw all the way. Why? Because your left bound of x is going all the way. This is one piece of the graph. The question is, if you want to make the second one like a continuous from here, you could draw the second piece anywhere, right? Second piece is nothing but a linear. I could draw the linear line anywhere after 1. I could draw like this. I could draw like that after 1. I could draw like this, or if I want, I could start from the point where I left earlier. Does that make sense? So you could draw any kind of straight line of beyond this point. The question is now, if you want to make it continuous entirely, that means if you want to join this straight line with this, what will be the corresponding A? For which value of A you could draw the piece of, you know, the linear with this, the odd one. So in such a way, how can I find A? They are asking simply, what is the A value in order to make the function is continuous at 1? You need to make, you know, function continuous at 1. That's the question. Right? So if you want to make continuous at 1, what will be the corresponding A? How do you find that A? A could be any real number. What is your suggestion? If you
Would it
want
have to be
to,
the
go ahead.
would it have to be the same value that it left off at? So it would have to be a 1, wouldn't it?
Exactly. So whatever you left over from here, you know, the function value should be same as for the second piece also, right? For the first piece, remember the function value at 1 was 1. Therefore, the second piece also, ax minus 1 also should give you 1 function value when x is 1. That is correct. Very good. That means simply plugging, you know, x1 and equate that the value to 1. Okay. So what I'm trying to say is function value at 1 should be always 1 for both cases, right? For the first case, of course, you are getting 1. For the second case, take the function. For second case, my function is ax minus 1. I'm simply finding, you know, f of 1 for the second piece. Simply plugging 1 here, you will get a times 1 minus 1. That is a minus 1. This value is supposed to be 1 now. In such a way that you need to figure out a. What is the corresponding a then? A minus 1 should be 1. That means a should be 2, right?
So I'm a little confused with that because it says that x has to be greater than 1. So would x be 2 and the a could be 1, or?
Yeah, x should be greater than 1, but at the limiting value, it should be same value, right? At 1 limit value. You are correct, but it should give you the same value to continuous from the a, from that point to the right side.
Yes,
you are
sir.
correct, but what I'm trying to say is the limiting value at 1 should be equal to the previous y value.
Yes, sir.
Yeah, otherwise you cannot draw a continuous function, right? Because it should be defined at at that point. So a is 2. That means what? If a is 2, then if you go back and plugging into the second piece, your second piece is going to be, now if a is 2, that's going to be 2x minus 1, right? That means if you draw 2x minus 1 curve and 2x squared minus 1, so if you have enough time, later you can check, graph it, these two, and check whether they are continuing. They should be continuous everywhere, right? If you draw these two, after x is 1, your drawing should be like this. Function should be continuous. Okay, that's what they mean. Okay, so that is there. Again, yeah, this one I just explained about intermediate value theorem, and again our answers are there, so you just check the answer. Okay, this all, number 8 again, finding the one-sided limit. Let's see whether you understood. Just now I explained one-sided limit. Okay. When you're plugging 2, forget about that side. Okay, if you're plugging 2, what kind of value you will get? If you're plugging 2 in right away to this function?
0, x over 0.
That means what?
Undetermined.
No, x is now 2. You're plugging 2, right? X is approaching to 2. That means if you're plugging 2 right away, you will get 2 over 0, which is infinity. Am I right?
Right.
But now you are checking only one side. Therefore, you have to identify whether that is positive infinity or negative infinity. Anyway, your answer is going to be infinity. But I don't know what kind of infinity it is. Maybe positive, maybe negative. How do you check? Like earlier, I explained you, right? 2 is somewhere here. You are approaching from the right side, right? Choose one number very close to 2. I could choose 2.001. Okay. So if you're plugging that value into the denominator, so numerator is very close to 2. So I could pick that 2, no problem. Or if you want, you could pick that x value I chosen, 2.001. I'm simply plugging, 2.001 for my x. My x is very close to 2, but from the right side. So I'm plugging here 2.001, but subtracting 2. What is my approximate answer you may get? If you approximate your answer, my numerator is 2, approximation of 2.001 is 2. But what about the denominator? Could you tell me what kind of 0 you will get? Is that positive 0 or negative 0?
Positive.
Positive. 0, which is very close, positive. Therefore, your infinity is going to be now positive infinity. Do you see that?
Yes.
Because 2 over 0 is infinity, but which is positive, therefore positive infinity. So answer is positive infinity. Okay. Now look at the second one. Okay. Now 1 is constant. Forget about the constant piece. You are going to plugging, to the function here, right? So remember the limit properties you learned. If you have constant, you could write down constant separately, then simply plugging the limit in front of the function. Now my task is to find the limit of 2 over x when x goes to 0 minus. What is the meaning of 0 minus? X approaches 0 from the left. Am I right? Could you pick one number very close to 0 but coming from the left? Yes.
Negative 0.999.
It should be very close to 0, right? What about point 0, negative 001?
Yes.
You are telling 0.99, it is very close to 1. I need very close to 0. Okay. So my x approaches to 0 from the left. That means it is carrying negative sign, right? Therefore, if you're plugging the limit here, 2 is my numerator. Denominator x is very close to 0, but in the negative sense, right? Therefore, you will get very, very, very small number with the negative sign. Am I right? Do you understand that, please?
Yes.
Now, this is the catch. Already you have negative sign in front of the fraction. Then that negative and this negative will make what?
Positive.
Positive. Then what do you think? 2 over this number is very close to 0. Am I right? The denominator. So 2 over 0, which is again infinity. Anyway, if you see 0 in the denominator, always your answer is going to be infinity. But you don't know what kind of infinity is. Maybe positive, maybe negative. To check the sign, you have to plug in like this some values. That's what I'm plugging some values to check the sign. Now you see, you got positive sign because of that negative in front of the function. Now tell me, what is 1 plus infinity?
Infinity.
Infinity. Infinity is very big number. Once you add 1, 1 is nothing, right? Infinity compared to infinity, 1 is nothing. So infinity again, answer is infinity. Do you see that? Okay, the number 3 is not that much easy to understand. I'm going to explain by the graph. Okay. Number 3 is finding limit x goes to 1/2 from the left. Let me write down like a fraction. Remember, secant pi x is the reciprocal of cosine pi x. Am I right?
Yes.
Recall trigonometry. Secant x is nothing but 1 over cosine x. Now I have pi times x. Therefore, secant pi x is 1 over cosine of pi x, but I already have x in front of the, the function secant. Therefore, that is x over cosine pi x. Now, what is my task? My task, x is very close to half, right? That means approximately this answer is, you could plug in half, no harm of that in the numerator, because x approaching very close to half. But only the thing is, you could think of that, the denominator. What will happen to this piece when x approaches 1/2 from the left? That means your cosine pi times x will reach pi times, now my x approaching half positive, therefore you will get half negative, sorry. So that means now this is going to be cosine pi times half is pi over 2, but from the left. Do you see that? Now, what is my idea? My idea is to identify cosine pi over 2. What is cosine pi over 2, of course?
0.
0. So I'm going to put 0 in the denominator, but what kind of 0 I will get? Is that very close to negative 0 or close to positive 0? That depends on your, the value of cosine. I'm asking you, finding the cosine value near pi over 2, but from the negative side. What kind of 0 you will get? Is that from the negative side 0 or from the positive side 0? Do you understand my question? We know that cosine pi over 2 is 0, but what kind of 0? Is that very close to negative number or very close to positive number?
Negative.
How do you say it is very close to negative? Could you explain?
Well, it's pi over 2 from the negative side.
Let's see. I'm going to explain in the picture, okay? I'm going to look at the cosine pi x graph. Okay. My x is now approaching half, right, from the left. Now let me draw the graph of cosine pi over x. When x is 0, my graph is now cosine pi over x. So what is the y-intercept of cosine pi over x? You need to set x 0, right? If x is 0, cosine 0 is 1. Therefore, cosine graph is like similar to the cosine graph, like this. Okay, so half is here. Now cosine value is getting close to x half, but you are approaching from the left. That means if you look at the function is approaching 0, function value is 0, cosine pi over 2 is 0, but what kind of 0? Is that above the x-axis or the below the x-axis? Above the x-axis. But if you look at the function value very close to 0, that is why cosine pi over 2 is 0. But if you approach your curve from the left side of half, your answer is very close to 0, but above, just above 0. That means positive 0. Do you see that, everyone?
Yes.
Therefore, cosine pi over 2 approaching from negative is always going to be positive 0. Very much 0 answer, but positive 0. Now, what is the answer you get? Is that positive infinity or negative infinity? Yes, should be positive, right? Because you see the positive under the denominator. Am I right?
Yes.
Okay, if you want, you could just simply check the cosine graph as well without cosine pi x. You know cosine graph, right, everyone? No
Mhm.
confusion. Cosine graph starting with 1, then getting 0 at pi over 2. Okay, so if you want to find the value, left of pi over 2, graph is approaching 0 above, positive 0. Right? Suppose if you are asked to find, x approaching to the pi over 2 from the right side, then your 0 from the right side, your 0 should be under the x-axis, below the x-axis. So it should be negative number very close to 0. But in this case, we got positive because of the left. Okay? So make sure that you understand that concept. So that is there. Right? Okay, so we are in last problem. Remember, to find the vertical asymptotes, I earlier told you, you need to look for what? Look for the denominator 0, right?
Yeah.
Look for the values of x where denominator getting
Yes.
0. That is your task, provided numerator non-zero. Right? The first problem, very easy. When x getting 0, denominator getting 0, therefore vertical asymptote is 0. Right? Again, I have explained this in my answer sheet, and you go ahead and check there. Number 2, the given function was now 2 over x squared minus 9. If you could factorize, that is good. Yes, I know how to factorize this x squared minus 9, which is x minus 3 times x plus 3. Again, the denominator getting 0 for two possible x values now. X is 3 and x is negative 3. These two will give you now 0 denominator. Remember now, numerator 0 denominator. Numerator is non-zero. We are good. Therefore, we get here two vertical asymptotes now. X is 3 and x is negative 3. Right? So, you know how to draw the graph. If you want to graph this function and check whether you are getting two vertical asymptotes, you should get. Then number 3. Oh, number 3, you have more work. The given function is now x to the power 4 minus 16. Right? So you need to make sure that you factorize the denominator. Numerator can be factorized easily. X is the common, so you could write x minus 2. But if you look at the denominator, x to the power 4 could be written as x squared to the power 2, and 16 can be written as 4 squared. So if I use a squared minus b squared for the denominator, a is x squared and b is 4. Therefore, that could be written as a minus b and a plus b. Now again, one more time, different square, 4 can be written as 2 squared. Therefore, you could factorize further for the denominator, that is x minus 2 and x plus 2. These two pieces coming from the first and the last one you already, these 3 is not. X squared plus 4. So this is the final version of the given problem in terms of factoring, right? Now, is there anything canceling out?
X minus 2.
Oh, this is 2, right?
Yeah.
Yeah. So x minus 2 canceling, so you will come up with x over x plus 2 times. So you have to do like this. Now look at the denominator. For which value denominator getting 0? Only one value, which is negative 2, right? This guy, this parenthesis will not get 0, never get 0, because all positive numbers. So this is always positive. Only the first parenthesis will be 0 when x is negative 2. Therefore, you will get only one vertical asymptote for this problem. Okay, again, draw the graph and check. So this is the way to check the vertical asymptotes. Looking for the denominator getting 0, provided numerator not getting 0. Does that make sense?
Yes.
That's it for today. So